Next, we're going to shift our attention to tangent functions. Tangent looks quite a bit different. In terms of tangent, I'm going to show you where it comes from. We haven't really talked about this at all, but just so you get the idea of how do we come up with this graph, you can see a picture of it already as to what it looks like. But we actually come up with tangent by saying tangent is equal to tangent of theta is equal to sine of theta over cosine of theta. You'll learn more about that next year. But for now, just understand that tangent of theta comes from taking sine of theta divided by cosine of theta. Remember, sine of theta was our y values, and cosine of theta was our x values. So if I find the y value at 0 and the x value at 0, I'm going to take y, which is 0, over 1, divide it out, and I would get 0. I do the same thing with the other locations. 1 divided by 0. This one poses problems for us. This is what we would call undefined. At tangent of 180, we would have 0 over -1, which is 0. Sine of 200, or tangent of 270, we'd have -1 over 0, which is undefined again. And then finally, tangent of 360 would be 0 over 1, which is 0. Okay, again, that all comes from your unit circle to come up with those values. So I'm going to get rid of this and try and explain what's going on here. So notice the difference this time for tangent. At tangent of 0, we're at 0. And then I get to another 0 value when I get to 180 degrees. So we're going to say that our period is a little bit different. It's not 360 anymore. We're going to say that it is every 180 degrees. That is going to be our period for the tangent function. We're also not going to have an amplitude because you can see there's really no specific height that I'm reaching out of this. So as far as amplitude goes, it's always going to be undefined. There's nothing there for an amplitude. And then one last part. Those are those dashed red lines. Those are considered asymptotes. We know that when we have an asymptote, those are locations that we can't cross. Those are undefined locations. So in this case, we came up with an undefined location at tangent of 90. We would say that there's an asymptote there, and we came up with an asymptote at 270 because we also had undefined. I'm going to ask you to come up with those locations as well as stating what your amplitude and your period is. Okay? And it's not terribly difficult to find. So we're going to try an example that comes from this. Find the period of this and then graph the function. I'm going to actually label out quite a few things. First, dealing with writing down what is the amplitude, period, and then I'm going to call it our asymptotes on here. Remember, for your period, there is no period. It's undefined. A normal period would be 180, but just like what we did for sine and cosine, we take our b value, which is 2, except this time we take 180 divided by 2, and we get 90 degrees. Your asymptote is directly in the middle of where you first start and your first period. So you would have 45 degrees for your asymptote. When we graph this one, I'm going to require 2 cycles again. So we have one at 90 degrees. We have one at 180 degrees. Our asymptotes are located at 45 degrees. And then to find our next location, we're going to take 45 plus 90, add on a period, we would get 135. If I draw in the asymptotes, remember these are locations that we cannot cross. It's going to look something like this. I know that there would be another asymptote over here. I'm not going to worry about that for now. Your first location would look like this. Your next one would look something like this. And like that. That's what tangent would look like. We'll do one more. This time find the period of a half tangent of theta, then graph the function. So we're going to do the same thing. I want to write down what's the amplitude, period, and where are your asymptotes. Period, or amplitude, excuse me, is always undefined. They may try and throw a half in there to throw you off. It doesn't do much for us. Our period, we would take 180 divided by our b value, which is 1. Our asymptote is our period divided by 2, which is 90. And then you can graph this one as well. Our first cycle is at 180 degrees. Next cycle would be 180 plus another 180, which is 360. Our asymptote directly in the middle of 90 degrees. 90 plus a period of 180 is 270. Draw in those dashed lines. Tangent function. There's one. There's the second one. And there's the third one.